Welcome everyone. I'm going to be talking to you about blockchain and Web3. So let's make a start. So what is Web3? Well, to understand that, let's take a step back and let's look at Web 1 and 2. Web 1 was the very first websites ever created where you could just read content. Web 2 was being able to register, go to Facebook or Instagram, create your own profile and start posting your own content as well as reading other people's. And that brings us to Web 3, which is where we're transitioning into today. And that's us making the decision that we want to own our own data. We don't want to allow companies or corporations to store our information in centralized databases. We want to store all of our information on a public blockchain, and we want to have the keys to it and control that ourselves. So now let's look at an example of our centralized financial system as we have it today. And let's just take a look at this. So if I want to open up a bank account, then I'll have to go to a commercial bank and I'm going to have to give them all of my information before I can open that account. I have to tell them my full name. I have to give them my address, my phone number. They're going to want to see identity documents, and they're probably want to know other things like my income as well. Now, if I wanted to do something like a cross-border payment, then I'd submit that transaction to the bank, and the bank would have to move the money and update the balances using a centralized ledger. Now, again, in the context of a cross-border payment, this would be very slow. It can take several days, if not longer. It's very expensive. There's a lot of fees involved. And of course, for hackers, there's only a single point of attack. Now let's compare that to blockchain. Well, with blockchain, that transaction could be done within seconds and would almost be feeless. So there's a big difference there. Now let's take a look at an example of Web 2. So for Web 2, this is pretty much you being able to go to a website and register. So typically you'll provide your name, you'll create an email and password, and depending on what you're signing up to, you might provide additional information. You might give them your address or your phone number. And that company will store your information, again, in a centralized database, probably on AWS or Azure or something like that. But of course, there are clear issues with that. So we have to trust that the company we're signing up to is going to be responsible with our data. And of course, there is always going to be a risk of data breaches where our information can get leaked online. So now I'm going to be moving into blockchain. This is, of course, decentralized. So let's start with Ethereum and talk about Ethereum addresses. So obviously on the blockchain, you don't have accounts, okay? You have addresses. And in the case of Ethereum, I've got an example here of an Ethereum address that you can see here. So an Ethereum address usually begins with 0x. It is a hexadecimal number. And with every address, you have a private and public key, and your Ethereum address will actually be derived from your private and public keys. But it is a hexadecimal number. Again, it begins with 0x, and then you have 20 bytes. It's a 20-byte number. Now, there are two different types of Ethereum addresses. There is an externally owned address. This is a normal address that you would have if you simply own some Ethereum. It doesn't really matter if you keep your Ethereum on a centralized exchange like crypto.com or Coinbase, or if you store your crypto in a hard wallet offline using a ledger device. It doesn't matter. You will have an Ethereum address that's associated with you. And the fields on a externally owned address would just be your balance, which would be, of course, the amount of ETH that you own, and a nonce number. Now, the nonce number is simply the number of transactions that have occurred on the network associated with that address. So as you can see, it's not associated with you personally. Your name isn't there, your address, your personal information. You just have an address. You own the keys to it. You have the private key, which you should never share. And the only things that you'll have on that address would be your balance and a nonce number. Now, the other type of address that you can have is a contract address. Now, this is, of course, where we would store a smart contract. The only difference is that it has additional fields. So in addition to having a balance, because you can actually store Ethereum on a smart contract, and a nonce number, which I've already told you what that is, you'll have a storage hash, which is where you can store data in memory on the smart contract, and a bytes hash, which is where you'll actually store the code related to your smart contract, and that's stored in binary code. Now, we'll talk a little bit more about this moving forward in the next slides, but for now, let's just focus on externally owned addresses. But the first thing that I'm going to talk about is actually going to be the Ethereum network. This is often thrown around, the network, the Ethereum network. But what is it? So the Ethereum network is made up of nodes. Nodes are just computers that are running some kind of software that connects them to the network and allows them to perform certain actions. You have different types of nodes. You have full nodes. These are nodes that have a complete copy of the ledger and the Ethereum state. You have other types of nodes, for example, miners. Now, miners will not have a complete copy of the ledger, but what they will have is responsibilities to try and mine the next block on the blockchain and actually mine transactions. But all of these nodes are linked and in constant communication. And another thing that's important is that each node has one vote. And before a block can be added into the blockchain, all the nodes have to be in agreement. So that's very important to understand. But we'll come back to this. But for now, let's move on and let's talk about how transactions are executed on the blockchain. So I've already talked to you about Ethereum addresses. I've shown you the information that's kept on addresses. It's just your balance. And I've already told you about your private key, which we can talk a little bit more about now. But when you create a new transaction, you submit that to the blockchain. Within that transaction, you're going to have some common information. So you're going to have the to and from address. So obviously, this is just where the Ethereum is coming and where it's going to. You're going to have a value. Now, the value that you can see here, this number might look a bit strange to you, but that value is actually an amount of Ethereum in Wei. So just as we have different units of measurement for things like weight, we have different units of measurement for Ethereum, and a very small amount of Ethereum is measured in Wei, and that is the value that is submitted within the transaction. It's submitted in Wei, and the number that you can see here is the equivalent of 1 ETH. And of course, in addition to that, you have the gas fee. So this is the gas fee that will be paid to the miner for mining and completing this transaction for us. And that is also there. So once you create that transaction, something that's really important to understand is the network needs a way to verify that this is a valid transaction, that you've submitted this transaction yourself. Otherwise, think about it. Anyone would be able to go onto the blockchain, find an address that has Ethereum, and then send that ETH to themselves. So there needs to be a way to verify that this is a valid transaction. The way that works is, as I've already mentioned, every Ethereum address has a private key. Now, this private key is just that. It's meant to be private. You should never share your private key with anybody, because if a hacker was able to capture your private key, they'd be able to steal all of your crypto. So it's essential that you keep this private. But your private key will be used to sign the transaction, and then the network will verify the the transaction using your public key. So it's important that you always keep your private key safe, but your private key will also be used to sign transactions that get submitted to the network. Now, once that transaction has been submitted to the network, it will be added into the mempool. The mempool is where all of the pending transactions are kept. Thousands of transactions are added into the mempool every day. And again, these are just pending transactions. Now, this leads me perfectly into talking about consensus algorithms, because this is how networks achieve finality on transactions. There are a number of different consensus algorithms. So, for example, both Bitcoin and Ethereum use proof of work. Cardano uses proof of stake. The upgrade to Ethereum 2.0 will actually move Ethereum onto proof of stake, which is considered a lot more environmentally friendly, and we'll talk about why shortly in the next slide. But if you want to learn about some of the others, so for example, Solana uses something called proof of history. But for now, let's focus on proof of work, because again, we are talking about Ethereum and Bitcoin. So how does proof of work work? Well, when we want to mine the next block, then transactions will be taken out of the mempool, they'll be ordered, and they'll be added into the next block. At that point, miners will start competing with each other to run a very complex series of calculations that will eventually lead them to the next nonce number in the blockchain. Now, once it's found the nonce number, it has to be agreed by the network. So all the validators on the network have one vote, and they all have to reach an agreement that that is the right number. Once they are in agreement, that block can be added into the blockchain, and the gas fees associated with mining that block will be released and rewarded to the miner. Now, this is why proof of work, Bitcoin and Ethereum today, is considered not to be environmentally friendly, because if you have 100 miners all competing to mine the next block, and only one miner is going to be successful, that means that 99 miners wasted all of the energy they invested in trying to mine that next block. So it's very inefficient, and it causes a lot of energy to be wasted. So now let's take a look at proof of stake and see how that's different. So proof of stake is considered to be more environmentally friendly, because instead of miners competing with each other, the network will select a single validator and reward them with the next block. Now, they'll pick the validator based on the amount of tokens that they are staking, which means that they are rewarding the rich. Now, you might say that's unfair, but I'd say it's the same on proof of work, because if you have more computing power, so for example, if you have a factory of computers and you're trying to mine Bitcoin with all of that resource, you're more likely to be successful than someone that has a smaller setup in their apartment. Compare that with proof of stake. If you're able to, for example, buy 1,000 tokens and stake that, and someone else is only able to buy 100, then the person with 1,000 is 10 times more likely to be rewarded the next block. So either way, proof of work or proof of stake, it does reward the rich. There has been some proposals to make this more fair, but as of right now, this is how it works. I don't think it's a massive issue, but it does reward the rich. So that's just something to be considered, something to be aware of. But it is considered to be more environmentally friendly, because unlike proof of work, miners are not competing with each other, and only one validator at a time will be rewarded the next block. Now, something else to be aware of when it comes to staking is that anyone can stake their coins. So if you own the tokens are used to run and maintain the network. So you can actually give your coins, you can lock up your coins on the network and earn a percentage yield on your coins. So if you wanted to buy some Cardano, for example, and rather than just keeping it in a cold wallet where it's going to sit there until the day comes that you finally want to sell, you can actually put your coins to work and you can actually lock them up for a period of time. For example, it could be 6 months or a year. And over the course of that year, you'll earn 7% on those coins. So it's a way of actually earning money on your coins. There are some things that you need to be aware of when you try and stake. For example, if there is a price change, you will not be able to sell your coins. So when you lock up your coins and you stake them, you'll stake them for an agreed period of time. So for example, 6 months or a year. So that means that you're not going to be able to sell those coins if the price goes up or if it goes down, because your coins are going to be locked up. So that's just something else to be aware of. Also, you have to also make sure that you are confident in the validator that you've selected to stake with. Because if the validator goes offline, the network may punish that validator and they will take a small percentage of the coins that they're staking. So that's called slashing. And if that happens, that does mean as well, you will lose some of your coins. So there are some risks as well as benefits to staking, but it's something that it's useful and interesting to learn about. And this is an illustration of what the blockchain looks like and the fact that every block has the hash of the previous block, which means that every transaction that occurs on the network is final and cannot be reversed. If anything changes in one of these blocks, then the nodes on the network will notice and that block will have to be remined. So let's talk about Web3. Now, the first thing that I want to tell you, which you should be happy to hear, is that it doesn't change the technology that you'll use to write the front end of your website. So if you're working with React, Angular, Vue.js, or whatever you might be using, HTML and CSS, you can continue to build websites the same way for your front end. When it comes to writing smart contracts, well, that will depend, the programming language that you'll use will depend on the network that you're building on. In the case of Ethereum, it's Solidity. I will say, if you are looking to learn a new programming language to start writing smart contracts, I recommend Solidity because although some networks don't use Solidity, so for example, Cardano, they have their own programming language. A lot of networks, a lot of them are picking Solidity because it's hard enough to attract developers to start building on their network, but asking them to learn a new programming language is going to make that even harder. So they want their developers' skills to be as transferable as possible. So in an effort to actually attract developers to start building on their network, they are using the Ethereum virtual machine. They are actually going to allow you to write contracts using Solidity. So if you are learning a language, I recommend Solidity because apart from using it on Ethereum, which is the market leader, a lot of networks will use Solidity and do today. For example, Hedera Hashgraph, they now support EVM. So yes, I recommend learning Solidity. But again, coming back to this diagram and Web3, you will write your smart contracts in Solidity. That will be compiled into a JSON file. Within that JSON file, you'll have information about your smart contract. For example, the bytecode, the binary code that gets ultimately migrated and deployed to the Ethereum network. It's in that JSON file. But actually that JSON file will also be used on the front end. So we will use a JavaScript library called Web3.js, and that will actually load your contract and allow you to call functions that are on the smart contract using Web3.js. And when you want to actually execute one of those functions, you'll actually make a call using Web3.js, but we need a way to actually format that request. And to do that, we use MetaMask. Now, MetaMask is a very popular crypto wallet for Ethereum and Ethereum wrapped tokens. And whenever we make we call one of those functions, MetaMask, which is a Chrome extension, will actually be used to format that request, and it will actually send that request to the Ethereum network for us. But it's also used to sign transactions. So if I, for example, if I want to do a transaction, I've already explained previously in earlier slides that transactions have to be signed, and you'll be able to actually log into your crypto wallet using MetaMask and sign that transaction in the browser. And I'm going to show you an example of a decentralized application shortly, but this is a really high level overview of what you'll be working with. Before we jump into a quick demo of a dApp that I've built, I want to just quickly give you some additional information and maybe just put a bit of a curveball for you. Because so far everything that we've talked about has been blockchain, but there are alternatives to blockchain, and one of them is Hashgraph. You've also got DAG, Holochain. Now, I really like Hashgraph. I think there's some clear potential here, and if nothing else, I think we can just marvel at the genius of it. So before I can explain Hashgraph, I just want to jump back to an earlier slide where I showed you an example of the Ethereum network. Now, remember the point that I made that before a block can be added into the blockchain, all the nodes have one vote and they all have to be in agreement before that node can be added into the blockchain. Now, that's very slow and very inefficient. And that is exactly what Hashgraph has solved using their Gossip protocol. So the way that this works is it's not a blockchain, it's Hashgraph. So it starts with two nodes, and then each of those two nodes will tell two nodes, and before long, we've gone from 2, 4, 8, and within 10 steps, we've reached 1,000. Within 20, we've reached 1 million, and within 30 steps, we've reached 1 billion nodes. Now that alone is not enough to reach a consensus, but at the same time, those nodes will be telling other nodes what they know about other nodes on the network, which sounds a bit confusing, but it will actually share information like timestamps and things like that. And before long, these nodes on the network don't need to vote because they already know how all the other nodes on the network would vote. So it's much more efficient, it's much faster, and it's, to be quite honest, it's just an ingenious invention. And I'm a big fan of Hedera Hashgraph. So I'm now going to demo a decentralized application that I have running locally. This is a faucet application, which basically means that I'm able to donate or withdraw Ethereum to and from my smart contract. As I mentioned before earlier in this video, you can also store Ethereum on smart contracts in addition to our smart contract code. So as you can see, I can see the balance of the smart contract. I can connect to my wallet. I have MetaMask installed on the browser, and I can donate and withdraw Ethereum from the smart contract. And before I actually demo that, I just want to mention that I am running Ganache locally. This is a local Ethereum virtual machine that I'm running locally for test purposes. And of course, these are the test accounts that I'll be using. So let's go ahead and connect to my wallet. So I'll just have to enter in my password. There you go. You can see that this is my wallet. I can switch accounts. So I could go to this account, or I can come back here. You'll see the address changes. That's the wallet that I'm currently connected to. I can see the amount of ETH I have in my wallet. And I can obviously, within the application, I can see the amount of ETH that's currently stored on the smart contract. And I can also donate 1 ETH. So you're going to see this should go to 3.7. So I'm going to donate one of my ETH, right, from my wallet. So I'm going to go ahead and click that. That's going to pop up and it's going to tell me the amount of ETH that I'm sending. It's going to show me the gas fees and it's going to ask me to confirm it. When I confirm it, it's going to basically sign the transaction and submit that to the network. So I'll hit confirm and that's it. It's very quick because obviously it's a virtual machine, running locally, but that is it. So I've now added in 1 ETH to this smart contract. Now, just like I did before, just to show you, the balance has updated as well. And just as I did before, I can withdraw funds. So this should go to 3.6. So if I withdraw it, again, this time I'm seeing that I'm withdrawing. I can see the gas fees involved and hit confirm. Again, signed that transaction. I've withdrawn the Ethereum. And then I can sign out of the application just by locking my wallet. So if I lock this, again, I have disconnected from the application. Okay, so a quick disclaimer. I'm not going to be going through the code line by line. I'm not going to be writing any code. I'm going to keep this very high level because I think that, we should have dedicated tutorials where we actually work on building our own decentralized applications. And I can teach you everything about Web3 that you'll need to know. But for now, I want to obviously just go through an example of a repository, be it the demo of the application I just showed you, and just show you and introduce you to some of the architecture and what you'd be looking to expect on a decentralized application. So of course, we have our contracts folder, and in here I have my faucet contract where I've got all of my Solidity code, and I've created payable functions that I can call on the front end. As you can see here, this is a very special function that you can define on your smart contracts that are payable, but I have other functions too that have other purposes. Again, the purpose of this video, part of the tutorial, is not to get too much into the code. But once you've actually deployed that contract and you compiled the contract, you'll compile it into a JSON file. And I've created a utility function that allows me to load that contract on the front end. So I'm passing in a contract name and then I'm getting the JSON file. Now that JSON file is very important because it actually contains the Ethereum address of that smart contract that will allow me to actually call it, right? So if I come back into app.js, and again, I'm going through this really quickly. And again, this was a very simple application. I've not even created separate components. All the code is in one place because of simplicity. This was not a production project. This was just a demo application. I'm storing in the state a provider, Web3, and a contract. And I'm executing that on the init of the component. So in this case, I'm using the useEffect hook. I'm calling my utility function to get the faucet contract, and I'm passing in the provider. I'm updating with Web3, the provider, and the contract. I'm storing that in state. And then I'm actually able to execute the functions on my contract. So I've got a function here to add funds, and I'm actually calling it the add funds function on my contract. You can see that add funds function here, which I'm defining on my smart contract. Within the smart contract itself, you're able to create, your interface, which is where you define the skeleton of your contract. You can handle ownership, and you can do a lot more. But again, this is not really the right time for me to be going through the code too much. And then, as you can see, this is a very simple component. in terms of the UI and CSS, it's very straightforward. Now for some additional information and resources I think will be useful to you. I recommend that you visit etherscan.io. You can come here and check out live transactions that have occurred on the blockchain, as well as much more. So for example, I can come and view the latest transactions. If I select something like this, I can see the amount that's been transferred, the gas fees, the to and from address, the gas price. I can see all the information about real transactions that have been executed on the network. So for example, here, this was someone sending $24. And I can see the address, I can go to the address, I can see all the transactions that have occurred on that address, the total balance. So everything is public on a blockchain, and you can really start to understand that when you're going through this website. You can also see the latest blocks that have been mined and go into those. And you can also, what I also think is quite useful is the gas tracker. And this is going to change depending on the network congestion at any one time. But I recommend that whenever you're going to send some Ethereum, I recommend that you check these the levels here to make sure it's a good time before you execute that transaction. Now, I also mentioned that when you are sending Ethereum, you're sending it in a smaller unit of measurement, which is Wei. And this also illustrates it here. So for example, 1 ETH, you can see the conversion. And as I change this, you can see. So this is just a useful converter I recommend you can also use. And then finally, I really like this. Just illustrates everything that I've tried to explain here. It's called ethviewer.live. You can hover over them, so you can see this is actually 330 ETH being executed on a smart contract. You see normal transactions and the amounts as they're sitting in the mempool before they're added into the next blocks to be mined on the network. Don't forget to like, comment, and subscribe. Turn on the notifications so that you know whenever I upload a new video. And check out my website, simpletut.com. I'll post a link in the description of the video. You'll find all my other courses there. Thank you and goodbye.